or it's 1 mark per minute, more or less. Right, let's begin. Okay, so the first calculation we had to do was to ignore C and work out the force between A and B. So the force of A on B, so we label it as F subscript AB. So that will be K, QA, QB over R squared. If you had Q1 and Q2, not a problem, but it's nice to adapt that formula to the subscript that we used here. Makes it easy in terms of your substitution. Right, 9 times 10 to the 9. QA is 3 times 10 to the minus 9. QB, 2 times 10 to the minus 9. Divided by the distance, which is 0,007 squared. Remember, you need to convert that to meters. I just want to fetch my calculator. Well, so what do we have? 9 times 10 to the 9 times 3 times 10 to the minus 9 times 2 times 10 to the minus 9, close bracket, divided by 0.007, close bracket, squared, equal. Right, I get 27 over 24,500, converting that to decimal. Right, so now that is in the decimal. How do you convert that to scientific? Now on the calculator, you have a shift button, and on the right hand side you've got a mode. So you press shift mode. You will get all of this stuff on the display. Number 7 is scientific. I should press 7. Then it gives you scientific 0 to 9. Now 0 to 9 would mean how many numbers do you want to be displayed? So for example, if I want 3 decimals plus the number in front of the decimal makes it 4. So press 4 and S to D again, and then what the calculator does, it also rounds it off for you. Right, so that's 1,102 times 10 to the minus 3. One comma 102 times 10 to the minus 3 Newton. And the direction, both are positive, therefore B will be repelled to the right. Next, I now want the force of C on B. So that's KQC, QB over R squared, which is 9 times 10 to the 9. QC is 6 times 10 to the minus 9. QB is 2 times 10 to the minus 9, divided by 0,01 squared. Times 10 to the 9 times 6 times 10 to the minus 9, open brackets, 2 times 10 to the minus 9, close bracket, divided by 0.01, close bracket, squared, equal 1,08 times 10 to the minus 3. 1,08 times 10 to the minus 3 Newton. Right, and then B and C are also both positive, so therefore C will repel B to the left. Right, now that we have the magnitude of the two forces, now we need to go and draw the free body diagram. So that is charge B. Due to A, it's moving to the right, so that is the force of A on B. Due to C, it's going to the left, that will be the force of C on B. And now we want the net force. So F net will equal to the sum of those two. But now look at those numbers. I see this one is slightly larger. Hence, I am going to take to the right as my positive direction, and therefore the left will be my negative direction. However, when you're writing this formula for the calculation of your net force, it must be the addition. It must be the addition of vectors. So therefore that will be FAB plus FCB. And then the substitution step, now you bring in the sign. So that becomes plus 1,102 times 10 to the minus 3 minus 1,08 times 10 to the minus 3. Okay, I get an answer of 2,2 times 10 to the minus 5 newtons. And it's a positive value, so therefore that will be to the right. Alright. So last week we did where C was moving, A and B were fixed, and therefore both the forces was to the right. Now by keeping A and C fixed, B is what is free to move. What do we find? We've got forces in both directions now. And we still need to add the forces, but in the substitution step you bring in a negative. You could have, if you so wish, made this maybe a plus, and then in a bracket put in the minus sign. That will also be acceptable. Okay. And then you end up with a positive value, and because we selected the right as positive, therefore the resultant direction will be to the right. Alright. I hope if there's any questions, please may put it into the chat. If not, I'm then going to move on to the next question. Right, and that's now question number 3. I'll just go back to my board if there's anybody who wants to complete any corrections. I'll give about 30 seconds if there's any corrections to be done, and then I'm going to proceed to question number 3. Okay, right, let's move on. Question number 3. Question 3, we now have a situation where the charges are at right angles. Now, in terms of the syllabus, and I want you to understand how the examiners are thinking, how our teachers are thinking, and what kind of questions we will be setting. in terms of the CAPS syllabus, we can only ask you to determine the resultant force or the net force that the charge which is placed at the right angle. That means I can only ask you, what is the net force that C experiences? And the reason for that is that at school level, we only want to use in physical sciences the theorem of Pythagoras and grade 10 trigonometry in order to calculate the direction. So we do not use sine rule and cosine rule, which you would have probably learned in mathematics, maybe in term 2 or term 3. Right, we try and keep it simple. However, if there's any of you who wish to do physics 1 at university or college in 2 years' time, then you could also be asked to work on the net force on A. Or you could be also asked to work on the net force on B. If you work out the vector diagram on A and on B, it will not be a right angle. And hence, you would then have to use sine rule and cosine rule. But in the CAPS syllabus, we try and keep it simple. We only want the net force on C, which is at the right angle. So when you draw your vector diagram, or your free body diagram, you will end up the right angle at that point. Okay, so that's the background. Right, so what do we have here? 3 charges, A is plus 6. Now, if you have a question of this type in an exam, where the charges are not placed on the diagram, then I would suggest, as you read, put the charges on the diagram. So A is plus 6. Microcoulombs. Note it's now micro, which means it will be 10 to the minus 6. Unlike the previous question, where you had nano, which would have been 10 to the minus 9. B is plus 2 nanocoulombs, and C is minus 6 nanocoulombs. Right, 3 charges A, B, and C are placed as shown in the sketch below. Charge A and charge B are fixed, as I mentioned, while charge C is free to move. And the angle at C is 90 degrees. Right, so we are told that is 90. Determine the electrostatic force that C experiences as a result of A and B. Right, so firstly, the charge on A, so once again you ignore B, and you only work with the force between A and C. Then 3.1.2, you want the force, the charge C experiences due to B. So then you ignore A, and you work with the force between B and C. Alright. Right, I'm going to remove this now from my visualizer so that I'm now going to work it out on my page. Right, and you can follow on your worksheet. Right, so 3.1.1. I want the force of A on C. So that will be K, QA, QC over R squared. Okay, perhaps maybe let me give you about 2 or 3 minutes to do that 2 calculations. You may continue. I don't want to disturb you. Alright, ladies and gentlemen, are you done? Okay, I think you've had enough time to work at the first part. Just want to remind you, the distance between A and C is not given. So, you have to first determine that distance. And being a right angle triangle, using theorem of Pythagoras, you would work this out to be 16 millimeters. Right, so that's the first calculation that had to be done. Work out the length between A and C, which would be 16 millimeters. Or, if you're smart enough in terms of your mathematics, you would realize that this is a 3, 4, 5 triangle. Because if this length was 3, this would be 5, and therefore that length would be 4. And then you multiply each by 4. So 3 times 4 gives me 12, 5 times 4 gives me 20, and therefore 4 times 4 will give me 16. Right, so that can be even done mentally. Right, so if your mathematics is quite astute, you should be able to see that. Okay, so that would therefore be 16 millimeters, and you've got that length as 12 millimeters. Right, I'm just going to switch screens. Right, so this is what you should have ended up with. Now, remember your calculators are already programmed to be on scientific mode. So now when I work this out, I got 1,266 times 10 to the power 3. Now if you have 10 to the power 3, which means you can convert it back into normal mode. Now 10 to the power 3, so when you convert it back to normal, then you will end up with 1265,63 newtons. Okay, it gives you a more accurate value. But if it is a very small number, let's say 10 to the power 5, or 10 to the minus 4, or 10 to the minus 3, then I would write it in scientific. But 10 cubed, you can see it's 1,265, something. Then, both A and C are negative and positive. So therefore C will be attracted towards A. So there was C, A was here, so C will be attracted towards A. That was a positive charge, and this was a negative charge. Then you've got B, which is out here, and B is positive. Okay? So therefore, two negatives and a positive, which C will be attracted towards B. Okay, so I made an error here. So this should be towards B. And that answer is 750 newtons. Right, so you've got two vectors acting towards A and towards B. Now last week I did mention, how do we get the resultant of those two? Remember, if you've got two vectors moving away from a point, the palm of your hand face each other, and therefore you need to complete the palm law, which is the parallelogram law. Right, and that's what we discussed on Monday, I think it was. Right, so we've got two vectors moving away from a point, so my resultant therefore would be move the vector parallel, any length, move the other vector parallel, and where the two meet, that will represent my net force, which is what we want next. Right, so I don't need the rest of the diagrams. So always draw your free body diagram. Right, so I'm just going to enlarge this free body diagram so that it's easy for you to see. Right, so C is there, and you have, that's a force of AC, and that will be the force of BC, which is 750 Newton, and this is 1265,63 Newton. And the resultant, parallel line, and there's my resultant. Okay. Next question. 3.2. Hence determine the magnitude and direction of the resultant force that charge C experiences owing to the influence of both A and B. So we now want the resultant force. What the examiner is insinuating, we need a magnitude and a direction. Okay? So, firstly, what are the magnitude? Now, you can decide, because this is the right angle here, this must also be a right angle. Remember, from your grade 9 mathematics, co-interior angles are supplementary. Which therefore means you now have two right angle triangles. You can then decide in which triangle you want to work on the angle. Okay, that's your choice. Right, so I'm going to decide I want to work in this triangle. So in that triangle, at the origin, I'm going to call that alpha. So that's the angle I want to work. So in that triangle, what do I have? I've got this side, which is 750, and then that side will be the same as this side, which therefore means this length, which is opposite the right angle, is now my hypotenuse. So therefore, if that is my hypotenuse, now you go and sit on alpha. If you sit on alpha and you look across, then this side becomes my opposite side, and next to it becomes my adjacent side. Remember, you've got a right angle triangle. So you can use your SOHCAHTOA in your calculation. Right, so the magnitude. Hypotenuse, so that's F net squared, will equal to F BC squared plus F AC squared. So that F net will then be the square root. Now BC was 750 squared plus 1265,63 squared. So the answer that you get must be larger than that, because it's obviously the hypotenuse. Right, so let's see. Square root of 750 squared plus open bracket 1265.63 close bracket squared equal 1471,163. 1471,163 if I want to do 3 decimal places, or 16 Newton. Right, so that would be the magnitude. Right, so that's my magnitude, and now we want the direction. Now, even though we worked out this magnitude, which is the hypotenuse, I would suggest not to use that in your calculation. Nothing wrong. You can use sine or cosine, but remember this is now a rounded off answer from a rounded off value that you substituted. So rather, preferably, use the values that you got from the previous calculation, which is my opposite side and my adjacent. And hence, I'm going to go with tan. So tan alpha will be opposite over adjacent. What's the opposite? 1265,63 divided by 750. But we want to find alpha, which means that tan must then be divided. So if tan goes to the bottom, now remember from mathematics, if I have 1 over x, 1 over x is x to the minus 1. So in this case, if tan is at the bottom, then I now want to bring tan into the numerator, then that becomes 10 to the minus 1 of 1265,63 divided by 750. And that is what we're now going to punch on the calculator. So shift 10 fraction 1265.63 divided by 750. Move the cursor, close brackets, equal 59,35 degrees. Right, so that is how you would work with the angle. And you don't need to say west of south or north of east, whatever, because there was no compass given in this particular question. Now, having got your alpha on your diagram, we as examiners can see where alpha is. Or if you wish, you can just have an arrow shown to that particular point. Right. Give you about 30 seconds of those just to finish off. So there's the answer. Okay. Right. Let's now move on to question number 4. Very similar to question number 3. Again, you have 3 charges at right angles to each other. Right. The question carries in total 15 marks. I'm going to give you about 10 minutes. Okay? Right, you've got 10 minutes, 15 marks, and then I'll take you from there after 10 minutes. At this stage, are there any questions from the teachers? Anything that you want me to explain? Or am I going too fast? Please, the teachers, you're free to give me a WhatsApp call directly, no problem. Yes, sir. Too fast. Okay. All right. No problem. I'll slow down. Thank you. Okay, you have about 5 minutes more. I'll give you guys about a minute more, 1 minute more. Okay, thank you. If you're not done, it's fine. I will give you time to work on 4.3 in a moment. So let's discuss 4.1 and 4.2. Then I'll give you a few minutes more for 4.3. Okay? I know I'm pushing you in terms of time. Righto. So this is what we have. Alright, so you've got 3 charges at right angles. A is plus 6 microcoulomb, B is plus 2 microcoulomb, and C is minus 6 microcoulomb. And we've got the distance between the two. Alright, so the first question asks us to draw a vector diagram showing all the forces acting on charge A. And note, charge A is at the right angle. Right, so your vector diagram. And the question carries 3 marks. And it says also indicate how the net force can be obtained. Right, so that is charge A. So due to B, which is positive, A, which is also positive, like charges will repel. So therefore A will be repelled by B. Keep in mind B is fixed. So A will then be repelled towards the left. So that will be the force of B on A. Then your force due to C. C is negative, A is positive, so therefore A will be attracted towards C. So that will be your force of C on A. Right, please take note of how you label the forces, and we discussed this on Monday as well. Then, how do we get the resultant? So again, we use the parallelogram law. So just please ensure when you draw these forces, you must use a ruler. It must be straight lines. And try to get them so that they are virtually at right angles to each other. Then you take your ruler and move that vector parallel, any length. Move the second vector parallel. Where these two vectors meet, and from your origin, that will be my net force. Right, so that will be 4.1 for 3 marks. Okay. Next, 4.2. Determine the electrostatic force that A experiences due to charge B. So 4.2.1, the force of A on B. No, sorry, the force of B on A. Please, you must get the notation right. So that will be K, QB, QA over R squared, which is 9 times 10 to the 9, QB. You see, now that you have everything on the sketch, don't run back to the question paper. work from what you have on the diagram. That's very important in terms of how you analyze the problem. So the charge on B is 2 times 10 to the minus 6. Charge on A, 6 times 10 to the minus 6. And the distance is 0,025 squared. Right, so fraction button, nine times 10 to the 9, close bracket, open bracket, 2 times 10 to the minus 6, open bracket, 6 times 10 to the minus 6, close bracket, go down to divide, 0.025, close bracket, squared, equal. Right, 172,8. 172,8 Newton, and that means with it. Right, so 172,8 Newtons to the left. Next question, we now want the force of C on A. Force of C on A will be K QC QA over R squared. 9 times 10 to the 9. QC is 6 times 10 to the minus 6. QA is also 6 times 10 to the minus 6. And the distance is 0,012 squared. Right, so let's work that out. Fraction button, 9 times 10 to the 9. Open bracket, 6 times 10 to the minus 6, close bracket, open bracket, 6 times 10 to the minus 6, close bracket, divided by, open bracket, 0.012, close bracket, squared, equal 2,250 Newtons, and that's towards C. Right, so 2,250 Newtons towards C. Right, so that's 4.2.1 and 4.2.2. Right, so I will now give you a minute or two to finish your 4.3 now. 4.3, we want now the net force. Now we've already got the vector diagram, but you cannot now go to 4.1 and mess around with that because we need to mark that. So what I would then suggest is when you get a 4.3, redraw that vector diagram, indicate your alpha or beta or theta, whatever you want. Alright, so let's say we're going to be working with that particular angle here. Let's call that alpha. So that all of us are working with the same triangle. And then we now want to work on the net force. That'll be about 2 minutes for that. Okay, are you guys done? Right, let's get back to our diagram, the free body diagram, because you need to understand where is your hypotenuse, where is your opposite side, etc. But always identify the right angle in your triangle. Why I do that? Because opposite that right angle is my hypotenuse. And I pencil that in. Remember, this is your rough work. So you can mess around on that sketch. Right, so opposite the right angle is my hypotenuse. Then you sit on alpha and you look across. And that becomes my opposite side. And next to it becomes my adjacent side. Right, so now you know exactly what you need to substitute. So tan alpha is opposite over adjacent. And my opposite side is this length, which is the same as that. Therefore, that's 172,8 divided by the adjacent. Adjacent is this side, which is 2250. And then we want alpha. So taking tan across becomes tan to the minus 1, or inverse tan of 172,8 divided by 2250. And then all you do is punch that into your calculator. Shift 10, fraction button, 172.8 divided by 2250, close bracket, equal 4,39 degrees. That's a very small angle, 4,39 degrees. And then you can just show that to your diagram, the arrow. Alright. Are there any questions, anybody? Now, if you are able to solve these problems, then you should be fine in this particular topic. Okay, now, these questions, like I said, dealt with Coulomb's law only. Right, I've got 5 minutes. At 10 o'clock, we will have a stretch break of about 15 minutes. So I've got 5 minutes so I can start the next discussion. Okay. Now, question number 5. We will come back to that in a moment. I just want to go back because here, the first question is talking about electric field. So if I go back to my page 2 of our notes, page 2, which dealt with all the summary that I have given you, at the bottom of page 2, we're now looking at the next topic on electrostatics, which is electric fields. Right, so I just want to quickly talk to that for about 5 minutes, then we can have a leg stretch, and then for the next hour, we will focus on electric fields. Now there are a few things here that you need to take note. We need to know what is the electric field pattern. And so I will show you how we're going to get the electric field pattern for different charges. The next thing is the electric field itself. Now what is an electric field? If you think of a soccer field, a netball field, a basketball field, that would be what we would regard as a region in space. Now space does not mean outer space. That space around you where you are seated now is space. So a field